I am Dr. L. Ramaprasad Reddy, Associate Professor, Department of Civil Engineering. Now we will discuss about the foundation engineering. It is a subject in civil engineering in third semester, uh, third year, second semester. So the main intention of this foundation engineering. So it is we will discuss about in a foundation engineering. The important topics are first of the soil exploration and soil stabilization and earth pressures and shallow foundations and bearing capacity criteria, shallow foundations with settlement criteria and deep foundations. So these are the topics we are going to discuss in foundation engineering. First of all, the foundation engineering. So what is meant by a foundation? So foundation is the lowest part of the structure, which is to transfer the loads coming from the superstructure to the soil safely. So the whatever the loads coming on the superstructure has to be transferred safely to the soil. So it is this that is why this foundation is the lowest part of the structure. So this is places very important role in design of structure, in the design of structures. So first of all, we will discuss in this one the site investigation topic now. So in the site investigation or the soil exploration. So in this exploration, so why it has to be explore the soil? What is the necessity of exploring the soil? So and what are the methods to explore the soil? And finally, what type of foundation is needed for the type of the soil? So these are the things we are going to discuss now. So first of all, the methods of soil exploration. So that is boring technology, the depth of boring and the spacing of boring holes, the samplings, the methods of sampling, that is thick wall samples and thin wall samplers, and bore log reports and data interpretation. So these are the topics we are going to discuss in this soil exploration. So so in the soil exploration has got three main parts of this one. That is, first one is site investigation, site reconnaissance and site exploration. First of all, we have to investigate the site, that is about the soil and hydrological conditions at the site to know the engineering properties of the soil. Next is site reconnaissance. It is an visual inspection of the site and study of topographical features. So, what are the topographical features are available, whether the topography of the soil. So, what are the this any boulders are there, any bushes are there, any that is different types of topographical features, and the site exploration to provide reliable, specific and detailed information about the soil and groundwater conditions at the site. So the main the important factor that where the site investigation is to obtain the necessary information about the soil and hydrological conditions at the site, to know the engineering properties of the soil. The process of determining the layers of natural soil deposits that will underlie a proposed structure and their physical properties is generally referred as site investigation. For this, the field and laboratory studies are carried out for obtaining the necessary information about the subsoil characteristics, including the position of groundwater table, are termed as soil exploration. Mainly, the site investigation consists of preliminary survey and detailed investigation. Right, in the preliminary survey consists of site visit, where to visit the site, local topography and drainage conditions, that is and natural features like streams, lakes, wells, etc. are nearby to the adjacent constructions, if any are there. So these are the preliminary survey where to conduct. And the detailed site investigation consists of mainly, that is making of boreholes, taking the soil samples at different depths, carrying out in situ tests, in situ, that is at the site, in situ tests like penetration test, plate load test, and that is a standard penetration test, all those things. Next, the testing of soil samples in the laboratory for physical and engineering properties. The purpose of main soil investigation is to obtain the properties of soil required for selection of type of foundation and design of foundation. These are the two major properties that we have to find out, that is a selection of type of foundation and design of foundation. So these are the two things, the purpose of soil investigation has to be done. So for this there are two types of exploration, that is general exploration, detailed exploration. So in general exploration, to get an approximate picture of subsoil conditions at a relatively low cost, it is opted for minor and routine engineering works. Whereas detailed exploration, it is to be carried out as supplement to general exploration, which gives detailed information such as soil properties, groundwater conditions. It is opted for large engineering works and heavy loads and costly foundations are involved. That is, whenever design in the construction of reservoirs, construction of dams, and construction of highway works, and so on. So, what are the methods of soil exploration? So, what are the important methods of soil exploration are mainly the open excavations, borings, and subsurface soundings, geophysical methods. So, these are the some important methods to explore the soil. Coming to that, first, open excavations, so or test pits are also called trenches, can be used for all types of soils. So, this cost of open excavations increased rapidly with the depth. So, if the depth is increasing, the cost of the exploration or excavations will be increasing. So, this method is ideal for shallow depths, that is up to 3 meters. So, up to 3 to 4 meters it can be used. So, more than that, so it is the cost will be increased. Coming to boring methods. So there are several boring methods to explore the soil conditions. They are mainly auger borings, auger and shell borings, wash boring, percussion boring, and rotary boring. So these are the some of the important boring methods. Coming to auger boring, mainly the augers are used for soft and cohesive soils. That is, hand augers are used for a depth up to 6 meters, and mechanical augers are used for greater depths. The recovered soil samples are badly disturbed, and so they are useful for identification purpose only, because the collection of collected samples will be in the disturbed state. So that's why for identification purpose only this method will be used. Auger is suitable for highway explorations at shallow depths. So for shallow depths these auger borings are mainly used. Next, auger and shell borings. So this method is suitable for soft to stiff clays, and in sandy soils also this auger and shell borings are used. Augers as shell with cutting edge, so it will have a cutting edge on teeth at the lower end, can be used for hard clays. So this hand operated augers are used for a depth up to 25 meters, and mechanical augers are used up to 50 meters. Next, coming to wash boring. It is a fast and simple method of boring for all types of soils except for rocky soils. So the main working principle of this, it will have a driving, a casing through which a hollow drill rod with a sharp chisel or chopping bit at the lower end, and the water is forced under pressure through the drill rod, which is alternatively raised, dropped, and rotated. Chopping and jetting action of the bit and water disintegrates the soil, from which we can get soil water slurry through the annular space between the drill rod and the casing. So we can guess the soil stratification from the rate of progress and the color of wash water. So this is a picture. You can see this the drill bit and how it will works, and how the water, how we will set the water during the drilling process. Next, coming to percussion boring. This method is suitable for soil and rock formations. Repeated blows of heavy chisel or chopping bit broke the rocks. Water is added to the hole during the boring process, from which we can collect the soil sample. Coming to rotary borings, it is a fast method of boring suitable for both soils and rocks. A drill bit is fixed at the bottom of the drill rod, and it is rotated by a chuck and is always kept a firm contact with the bottom of the hole, as shown in the figure. Here we use bentonite solution along with water to soften the rocks. Bentonite is a product from the barium sulfate, and this is extracted from the barytes, the minerals, a barytes mineral, where you will get this bentonite powder. The mud returning upwards collected for testing. So it is called mud rotary drilling. So it has shown in the figure. So how the process is taking place. like our drilling rig. Next, coming to subsurface soundings. So these are the previous methods which are used, that is mainly by exploring the soil, physical this thing, and the subsurface soundings is generally for determining the consistency of cohesive soils or relatively the relative density of cohesionless soils also. So the common procedure, that is a rod encased in a sleeve is forced into the soil and the resistance to penetration with the draw is observed. Variations in this resistance shows dissimilar soil layers. So what is the main advantage of these subsurface soundings is faster and cheaper than the borings. In erratic soil conditions, sounding can be used. The main limitation of these methods, the soundings gives no idea about the settlement characteristics of the soil, and soundings alone cannot provide sufficient data for the final design. So the mainly the subsurface soundings are, that is the testing methods, that is two common type of methods. They are, one is standard penetration test and cone penetration test. The standard penetration test, this is also called SPT test, standard penetration test. So the SPT is a common in situ test method used to determine the geotechnical engineering properties of subsurface soils below the surface soils. We can get the all information of this the engineering properties. The SPT are carried out in boreholes. The test will measure the resistance of the soil strata to the penetration undergone. So in this one, we will measure the resistance, that is the resistance to the penetration. So that is measured. So a penetration empirical corrections derived between the soil properties and the penetration resistance. The test is extremely useful for determining the relative density and the angle of shearing resistance of cohesionless soils. It can also be used to determine the unconfined compressive strength of cohesive soils. Coming to the tools for this standard penetration test, the important tools required to conduct this test are mainly the standard split spool sampler, drop hammer weighing about 63.5 kg, guiding rod, drill bit, driving head, or this is also called anvil. So these are as shown in the figure. So this is the figure where you will have the different that is what is anvil and what is drill bit and weighs, what is the weight of this one 63 point kg, that is called hammering, that is dropping hammer. So all are shown in the figure. So this is one more how the dropping hammer is there, and how what is the height of fall is 760 mm, and it falls on the anvil, and this anvil is connected to drill rod, and where this drill rod is will go into the soil, so that what are the penetrations required to drive into the soil, that is measured. So this is the standard penetration test. It will have first a seating drive of 150 mm. That is, so that is not counted for taking the number of that is penetration values. That is called seating drive. Next drive, that is after seating drive, that is the blow counts is total number of blows to drive sampler for last 300 mm or blows per foot. So that is measured, that SPT. So first we will give the first increment will give the seating drive, second and third increment will give the penetration value. So this mainly the test is conducted in a borehole by means of standard Fitbone sampler. Once the drilling is done to the desired depth, the drilling tool is removed and the sampler is placed inside the borehole. By means of drop hammer, 63.5 kg mass falling through a height of 750 mm at a rate of 30 blows per minute. The sampler is driven into the soil. The number of blows of hammer required to drive a depth of 150 mm is counted. Further, it is driven by 150 mm and the blows are counted. Similarly, the sampler is once again further driven by 150 mm and the number of blows are recorded. The number of blows recorded for the first 150 mm are not taken into consideration. This got seating drive. So the number of blows recorded for last two 150 mm intervals are n value. That is n is equal to number of blows required for 150 mm penetration beyond the 150 mm seating drive. If the number of blows for 150 mm drive exceeds 50, suppose for 150 mm drive it exceeds 50, it is taken as refusal and the test is discontinued. If it is exceeds, it is removed. The standard penetration number is corrected for dilatancy correction and overburden correction. So before the SPT values are used, the empirical correlations and in the design charts, the field n value have to be corrected as per IS 1231/1981. The two corrections has to be made, that is dilatancy correction and overburden correction. This dilatancy correction, silty fine sands and fine sands below the water table develop pore water pressure which is not easily dissipated. This pore pressure increases the resistance of the soil and hence the penetration number. So the Terjagi and Peck recommended the following correction in the case of silty fine sands when his observed value exceeds 15, that is ND is equal to 15 plus half n minus 15. This is the overburden pressure. From several investigation, it is proven that penetration resistance value is depend upon the overburden pressure also. If there are two granular soils with relative density of same, the higher n value will be shown by the soil with higher confining pressure. So with the increase in depth of the soil, the confining pressure is also increases. So the value of n at shallow depth and larger depths are underestimated and overestimated respectively. So the correction for overburden pressure for P naught is less than 75 kPa, that is n dash is equal to 4n by 1 plus 0.04 P naught. When P naught is greater than 75 kPa, that is overburden pressure, n dash is equal to 4n by 3.25 plus 0.01 P naught as shown in the table. So where n dash is the corrected value, n is the observed value, P naught is the overburden pressure. It is calculated by gamma into D, that is density of the soil and by the depth of footing, and that is whatever your depth of D is the depth of testing, gamma is the unit weight of the soil at the time of testing. During the testing, what is the density of the soil? So, the main precautions to be taken during the standard penetration test are: the split sampler must be in good condition, the cutting shoe must be free from the wear and tear, the height of the fall must be 750 mm. Any change from this will affect the N value. So, the drill rods used must be in standard condition. The bent drill rods are not used. And before conducting the test, the bottom of the borehole must be cleaned. So, these are the main precautions to be taken. The main advantage of this standard penetration test. So, mainly this test is simple and economical. The test provides representative samples for visual inspection, classification of tests, and for moisture content. The actual soil behavior is obtained through SPT values. The method helps to penetrate dense layers and fills, and this test can be applied for variety of soil conditions. These are the main advantages. Coming to the disadvantages of standard penetration test, SPT test, the results will vary due to any mechanical or operator variability during the or drilling disturbances. The test is costly and time consuming. The samples retrieved for testing is disturbed samples. So, the test results from SPT cannot be reproduced. The application of SPT in gravelly soils, cobbles and corrosive soils are limited. So, these are the disadvantages. Next, coming to the standard cone penetration test. The cone penetration test has become internationally one of the most widely used and accepted test methods for determining geotechnical soil properties. So, this is the cone penetration test or CPT test, which is having the penetrometer and a rig. It is connected as per the it is shown in figure. Mainly, the CP cone penetration test have the important operators are steel cone, friction jacket, sounding rods, sounding tubes or mantle tubes, driving and measuring instrument. Mainly, the capacity of equipment is available of 3 tons, 10 tons and 20 tons. So, the CPT test, the conduction of CPT test is called, this is also called Dutch cone test or static penetration test. The test method consists of pushing an instrument cone with the tip facing downwards into the ground at a slow controlled rate. The cone is having 60 degrees apex with a diameter of 36 mm. So, we will have measurements, that is cone or tip resistance QC or QT, sleeve friction Fs, water pore pressure UB, other variables, that is our shear wave velocity as shown in the figure. The cone penetration test is conducted. The test method consists of pushing an instrumented cone with the tip facing downwards into the ground at a controlled steady rate. A cone with base of 3.6 centimeters in dia and an angle of 60 degrees at the vertex. To find out the cone resistance, the cone alone and the maximum value of resistance is recorded. The cone resistance QC in kg per cm square is approximately equal to 10 times the penetration resistance, that N value. This test is very useful in finding bearing capacity of pits in corrosionless soils. So, the cone penetration, so the application, so the profile, it will give the profile of the soil, different profile of the soil, how the soil profile is there, and by it is recorded by sounding methods as shown in the figure. The main applications are the soil profile, that is stratigraphy, soil type identification, estimation of geotechnical parameters, that is strength, compressibility and permeability, evaluation of groundwater conditions, that is pore water pressure, and geo-environmental disturbances and compositions of contaminants. Mainly the use of cone penetration test is CPT are conducted to measure and evaluate characteristics of certain soils, that is soft sensitive silts and clays, and some coarse cohesionless soils such as stratification, soil types, relative soil density, and in situ stress conditions, and shear strength parameters, that is C and phi, cohesion and angle of internal friction. Thank you very much.